Chapter 4, Chapter 4, Section 1 is about dilations. Dilations are what we refer to as taking a diagram and either enlarging it or reducing it. Sort of like what happens when you go to the eye doctor, they put drops in your eye and they dilate your pupil, it enlarges, and then it reduces. So if we take a look at number 2, it asks for an image, or it gives an image, and it gives a pre-image, and it asks for the scale factor. So the way that I can tell the difference between the two is the figure that has the pre-image is the original. So let me just write a few things up here. So my pre-image is my original. And in this diagram, my original drawing is triangle A, B, C. The image is the new figure, and in this diagram, my new figure is triangle A prime, B prime, C prime. So if I'm trying to determine the scale factor, I need to compare my original point A, which is 2, 3. Point A is right here, 2, 3, with A prime. A prime is at 4, 6. And I noticed that the x and the y values were double. If I continue and I compare point B with B prime, again I notice that the x values and the y values again were double. So continuing that pattern, since each x value and each y value was multiplied by 2, my scale factor is 2, or we can say 2 to 1. What that means is my image is twice as big as my pre-image. In number 4, point G is at 3, 15, whereas G prime is at 1, 5. Point H, 3, 6. H prime, 1, 2. Point J, 15, 6. J prime, 5, 2. So what I noticed, each x value was divided by 3. We call that a reduction. So then my scale factor, when something is divided by 3, is 1/3. What that means is my image is 1/3 as big as my pre-image. My new figure is 1/3 as large as my original figure. So when the image is bigger, we call that an enlargement, and the scale factor is greater than 1. When the scale factor is less than 1, then the image is a reduction. time I have a pre-image of triangle ABC. Point A is 1, 1. Since my scale factor is 3, A prime is 3, 3. Point B is 1, 2. Since my scale factor is 3, B prime is 3, 6. Point C. So A prime, B prime, C prime is an enlargement of triangle ABC. Since the scale factor is 3, it's 3 times as large. Number 8, I have a scale factor of 2. Let's start with point E. So E prime twice E, 2, 4. Number 10, we have a scale factor of 5, which is another enlargement. So I'm going to take each of the vertices for triangle DEF, and I'm going to multiply each of those values by 5. Scale factor is 1/5. So I'm going to take each of my vertices, D, E, and F, and I'm going to multiply by 1/5, or take 1/5 of each value. 1/5 of 25 is 5. 1/5 of 15 is 3. 1/5 of 10 is 2. 1/5 of 20 is 4. And 1/5 of 10, again, is 2. instructions are. ABCD is a parallelogram. Highlight that. All right, so we have a parallelogram. Therefore, AB is parallel to CD. And AD is parallel to CB. So I have two arrows here. I'm going to go ahead and add two arrows on this length. And we have put in all the measures of the missing angles. All right. Let's start with supplementary angles. So I have a measure of an angle that's 48 degrees right here, and I can find its supplement by subtracting. We have some alternate interior angles. This angle that's 48 degrees is alternate interior to this angle, which is also 48 degrees. And therefore, the supplement of that is 132 degrees. This angle right here, that's 80 degrees, is alternate interior angles to this angle here, which is also 80 degrees. And therefore, the supplement is 100 degrees. There are other supplements. 48 degrees is supplementary to 132. 80 degrees is supplementary to 150. And now I can find the measure of angle E. So this is sum of the angles in a triangle is 180 degrees. Start with 180 minus the first angle, 48. Minus the second angle, AB, which leaves 52 degrees. I notice up here in the given, it says the measure of angle GCB is 60 degrees. So let me add that into my drawing. Angle GCB is 60 degrees. Therefore, we have 80 degrees, 60 degrees, that's 140, which leaves 40 degrees for the third angle in that triangle. Together, these three angles must add to 180. 80 plus 40 is 120. So that leaves 60 degrees for this third angle, which makes sense because this angle is alternate interior to this angle right here. So the third missing angle in this triangle, we have 60 degrees, 90 degrees. So the third missing angle has to be 30 degrees. Angle D is 120 degrees. The reason why this is 120 degrees is this angle and this angle are same side interior angles. And same side interior angles add up to 180 degrees. This angle is also 60 degrees because these two angles are also same side interior angles. started, and we need to determine how much fencing. So in order to do that, I need to find the missing side length so that I can find the perimeter of the triangle to determine the amount of fencing that I need. So I notice I have a right triangle, and in a right triangle, if I know two sides, I can determine the third side by using the Pythagorean theorem. So the question is, 8 squared plus 15 squared is equal to c squared. So I know that I'm missing the hypotenuse in this triangle, this right triangle. The hypotenuse is the longest side. That's my value for c. So I'm going to take the square root to find my value of c. So we're going to calculate the square root of 8 squared plus 15 squared. So C is equal to 17. So to find how much fencing, I need to add 8 plus 15 plus 17. Find the area of the shaded region. Find the area of the shaded region. So my plan to do so is to find the area of the large square. It's a square, yep, it's a square. And I'm going to subtract the little white square in the middle. And what's left over is the shaded region as seen in the diagram. So let's take a look. The length of segment AC is 9 radical 2. So if this whole side is 9 radical 2, then I can find these two sides by remembering the relationship of a 45-45-90, which says that the leg is the hypotenuse divided by radical 2. So if I want to go from the hypotenuse to the leg, I'm going to take 9 radical 2 and divide it by radical 2. So that gives me 9. So the area of my large square is 9 by 9, or 81. All right, now I need to find the area of the smaller square. The length from x to y is 4. So once again, if I want to find the leg of this 45-45-90, I'm going to take the hypotenuse and I'm going to divide by radical 2 to get this side. We'll call this side y. So to find the area of that square, I'm going to take the answer that I have in my calculator and square that answer. And the area of this is equal to 8. So to find the area of the shaded region, I'm going to take 81 minus 8, and I get an answer of 73 square units.